Hello and welcome to this lecture. Now that I have shown you how to use full text and term level queries with the query DSL, it's time to take a look at compound queries. Remember that compound queries consist of leaf queries or other compound queries. To start off, I'll perform a simple search that uses simple Boolean logic. The example is going to search for products with both pasta and spaghetti in the name. So let me just begin to type this out. Get e-commerce product / search, and I'll add the request body. I'll say query. The type is going to be bool, which allows me to use Boolean logic. I'll say must, which contains an array of conditions that must match. And in here, I'll specify queries of any given type. I'll say match, which is going to be an object in itself. And I'll say I want to match on the name field, and the value should be pasta. Let me go ahead and add a similar query. Name, and this time I want to say that it should be spaghetti, like so. So the conditions specified by the leaf queries within the must array must all be true for a document to match, just like the logical AND. The matches within the must clause contribute to documents' relevancy scores. So let me just go ahead and issue this request. And as you can see in the results, the only product that matches is the one that has both pasta and spaghetti in the name. But while the must clauses define conditions that must be satisfied, must not clauses define clauses that must not evaluate to true. This can, for instance, be used to exclude documents with particular values for particular fields, and I will show you an example that matches documents with pasta in their names, but where spaghetti must not be a part of the name. So let me just remove this leaf clause here, and after the must array, I'll add a must_not array. And in here, I'll add a match query similar to what I did above. It will also match on the name field, and it will be excluding documents with a value of spaghetti in the name. Whoops, I see I forgot a colon here. So now let me just go ahead and issue the request. And scrolling through the results will show that the product with both pasta and spaghetti in its name has been excluded. The bool query also has a should parameter. When one of the should clauses match, a document's relevancy score is increased. Otherwise, they have no effect. Therefore, should clauses can be used to increase the relevancy for certain documents that satisfy the search criteria but should have higher relevancy scores. When I said that should clauses only affect the relevancy scores of documents if they match and otherwise do nothing, there is one exception to this. If the search query has no must clause, then at least one of the should clauses must match. So in this case, the should clauses behave like the logical OR, where at least one must be true. If at least one must clause is present, then no should clauses are required to match, and in this case they only affect the relevancy score of matched documents. Let me show you an example of how the should query can be used. So I'll simply go ahead and change the must not clause to should, which will boost documents that have spaghetti in their names, but will not exclude ones that don't. So let's issue the request, and as you can see, the product with both pasta and spaghetti in the name is scored highest. So in this example, product names must contain the term pasta. I have also added a match query to the should clause, which looks for the term spaghetti in the product name. In the results, you can see that products with pasta in their names are matched. But you may also notice that a product with both pasta and spaghetti has the highest relevance score. Let me explain why. Because we have a must clause, then the should clause is optional and no match is required. However, documents where the should clause is true are assigned a higher relevance score. In this example, this is true for the product that includes both pasta and spaghetti in its name. Now let's see what happens if I remove the must clause. So I'll go ahead and remove this and run the query again. Because we no longer have a must clause, at least one of the should clauses must match. In my case, I only have one, so the match query must match. If we inspect the results, you can see that only the product that includes the term spaghetti in its name is matched. Now that we have seen how must not, and should clauses should be nested within bool queries, it's also worth mentioning that for even more flexibility and more complex queries, it's possible to nest bool queries inside any of these clauses. There are two more queries that I would like to mention. The first one is the function underscore score query, which lets you provide a function that can modify the score of documents that were returned by a query. This can be useful for boosting newly added documents or boosting documents based on popularity, for example. There's also a query named boosting, which can be used to reduce the score of documents that match a certain query. A positive query can be defined, which would be your typical query, as well as a negative query. Documents that match the negative query have their score lowered, and you can define by how much it should be lowered. There are other compound queries as well, but these were the ones that you are most likely to come across. So that's it for compound queries. Thank you for watching and happy searching.